بسم الله الرحمن الرحيم.
In this question, we have been asked to decide either the given values are divisible by 11, by 12, by 15, and by 25 without following the lengthy process. Just to apply here the test of divisibility or the rule of divisibility and to give our answer within short time. Okay, as far as the divisibility by 11 is concerned, if we take the sum total of the digits at odd places and the sum total of digits at even places, if we subtract one value from other, and if the answer is 0, then that value is divisible by 11. Or in other case, if the answer is 11 or that value which comes in the table of 11, again that value is divisible by 11. For 12, any value divisible by 3 and divisible by 4, that value is also divisible by 12 because it's 4 3s are 12. For 15, any value divisible by 3 and divisible by 5, that value is again divisible by 15. For 25, any value having 0 at unit place and 0 at 10 place, means 2 0 at the last, that value is divisible by 25. Or any value which last two digits, the value of last two digits, I mean the value at unit place, the unit at 10 place, if that value is divisible by 25, then the total value is again divisible by 25. Now let's come to the question. Here in the first part, we have been given 756 and we have to decide either this value is divisible by 11 or not. We are taking the sum total of the digits at odd places. At odd places, here is 6 and here is 7. If you take a sum total of 7 and 6, it becomes 13. And at even place, there is only 5. If you subtract 5 from 13, the answer is neither 0 nor it's divisible by 11. Therefore, this value is not divisible by 11. Now, here it's 6 and here it's 56. You know 56 is divisible by 4. So the first condition is met. The second condition is this value should also be divisible by 3. So we are taking the sum total of all digits present in this value. That 6 and 5 becomes 11 and 11 plus 7 becomes 18. And 18 comes in the table of 3. Therefore both the conditions are met. Therefore 756 is divisible by 12. For 15, it's not divisible by 15. Because if there is 0 or 5, that value will be divisible by 5. And the first condition is the value which is divisible by 5. And second condition, the value which is again the same value is divisible by 3. That value will be divisible by 15. So this value doesn't meet the first condition. Therefore, it's not divisible by 15. And again, it's not divisible by 55. Because for 45, they require 2 0 at the last. Mean at the unit place at the 10 place, or the value at the unit place at the 10 place should be divisible by 25. So these two conditions are not met. Therefore, I put here a cross and I declare that 756 is not divisible by 25. Now the second part that is 5820 for 11. I am taking the sum total of the digit at odd places and the sum total of the digits at even places. The sum total of the digit at odd places will be 0 plus 8 becomes 8. At even places 2 plus 5 becomes 7. If you subtract 7 from 8, here comes 1. 1 is not 0. And 1 can't be divided by 11. 11 was 11, that's another case. But if it was 11, then this value would be divisible by 11. But in this case, this value is not divisible by 11. For 12, two conditions are required. The value must be divisible by 3 and again the value must be divisible by 4. So by 4 is divisible because 20, the last two digits are 20 and we apply here the rules of the test of divisibility. 5 4s are 20. The first condition is met. And if you add 5 plus 2, 10, 10 plus 5, 15. 15 comes in the table of 3. So the both conditions are met. Therefore, this value of 5,820 is divisible by 12. For 15, first of all, it should be divisible by 3. Of course, it is divisible by 3. It's again divisible by 5 because in the last there is 0. Therefore, it is divisible by 15, but it's not divisible by 25 because this 20 is not divisible by 25. Therefore, I put here a cross like this. Coming to the third part, 7,400. If I take the sum total of the digits at even places and odd places, in odd places it becomes 4, and in even places it becomes 7. If you subtract 4 from 7, the answer is neither 0 nor that value which is divisible by 11. Therefore, that's again not divisible by 11. Coming to our 12. Two condition. The first condition is met because there are 2 zeros. When there are 2 zeros at the last, that value is divisible by 4. And 7 plus 4 becomes 11, and 11 is not divisible by 3. Therefore, the second condition is not met. I will put here a cross. For 15, the value must be divisible by 5 and by 3. Though this value is divisible by 5, but it's not divisible by 3. The one condition is met, the second condition is not met. Therefore, I put here a cross. For 25, any value having 0 at unit place, 0 at 10 place means 2 0 at the last, that value is divisible by 25. Therefore, the 7,400 is divisible by 25, and I put here a tick mark. 2,384. If I take the sum total of the digits at odd places, that will become 4 plus 3, 7. And at even places, that is 8 plus 2, 10. Subtract 10, 7 from 10 becomes 3. So both of the conditions are not met. Therefore, I put here a cross for 12. Yes, 84 is divisible by 4. And now 8, 4 becomes 12. 12 plus 3, 15 plus 2. 17, and 17 is not divisible by 3. The second condition is not met. Therefore, I put here a cross. And for 15, here it's 4, and whenever there is a value other than 5 or 0 at the unit place, that value is not divisible by 5. So the first condition is not met, whereas the second condition is again not met. Hence, this value is not divisible by 15, and 84 can't be divided by 25, so it can't be divided by 25. Coming to the fifth one, 6,500. If we take the sum total of the digits at odd places, it will become 5, and if we take the sum total of the digits at the even places, it will become 6. Subtract 5 from 6 comes 1. So the condition, both of the conditions are not met. Therefore, 6,500 is not divisible by 11. For 12, now here are 2 0 and 0, so it is divisible by 4. But if you take sum total of 6 and 5, that becomes 11, and 11 is not divisible by 3. The second condition is not met. Therefore, 6,500 is not divisible by 12. For 15, it should be divisible by 5. Yes, of course it is divisible by 5, but it can't be divided by 3 because 6 plus 5 becomes 11, and 11 doesn't come in the table of 3. The second condition is not met. Therefore, this value is not divisible by 15. And for 25, if there are 2 0 at the last, means if there is 0 at unit place, if there is 0 at 10 place, then that value is divisible by 25, and here are 2 zeros at the unit place and at the 10 place. In this case, 6,500 is divisible by 25. Coming towards 6, that is 8,235. Now, if we take the sum total of the digits at the odd places, there's 5 and 2 becomes 7, and at even places 3 and 8 becomes 11. If you subtract 7 from 11, So it will come 4, 4. It's not 0, and 4 can't be divided by 11. Therefore, both of the conditions are not met. And I put here a cross, which means that this value is not divisible by 11. For 12, here is 35. 5 means that is an odd number. When there is an odd number, that value can't be divided by either 2 or 4. So the first condition is not met. Here I will put here a cross. And for 15, it is divisible by 5 because in the last there is 5. And let's see either this value is divisible by 3 or not. 5 plus 3 becomes 8. 8 plus 2, that becomes 10. 10 plus 8, 18. And 18 comes in the table of 3. Therefore, both of the conditions are met. Hence, this value is divisible by 15. And for 25, this value is not divisible by 25. Because 35 can't be divided by 25 equally. So, I put here a cross. Now, this one, 4128. If I take the sum total of the digits at odd place and the digit at even place, it will be 8 plus 1, 9, and 4 plus 2, 6. If I subtract one value from the other, the answer doesn't come 0. Therefore, both the conditions are not met. I put here a cross, which means that this value is not divisible by 11. For 12, I have two conditions. The value must be divisible by 3. The value must be the same value must be divisible by 4. Let's see. Either this is divisible by 4. Yes, of course it is divisible by 4 because 28 comes in the table of 4. C is divisible by 3. 8 plus 2, 10. 10 plus 1, 11. And 11 plus 4, 15. 15 comes in the table of 3. Both the conditions are met. Hence, in this case, this 4,128 is divisible by 12. For 15, here it's 8. Whenever there is an even number at the unit place, that value can't be divided by 5. So the condition of 5 doesn't meet here. Therefore, I put here cross. And 28 can't be divided by 25. Again, I put here cross. Means that this value is neither divisible by 15 nor by 25. Now, the next one, 8,775. If I take the sum total of these odd digits at odd places, there is 5 plus 7, 12, and 7 plus 8, 15. So, the difference is if I subtract one value from other, the answer doesn't come 0. And the answer doesn't come that value which is divisible by 11. Both the conditions are not met. So I put here again a cross. Now for 12, it should be divisible by 4. No, it's not divisible by 4 because here it's 5 at the unit place. It's not in even number, it's in odd number 5. So it's divisible by 5 but not by 4. Therefore, one of the conditions is not met. I'll put here a cross. For 15, it should be divisible by 5. Yes, it's divisible by 5 because here is 5 at the unit place. And let's see either this value is divisible by 3 or not. So if we take the sum total of 7 and 5 becomes 12. And 12 and 7 becomes 19. 19 plus 8, 27. 27 comes in the table of 3. Hence, both of the conditions are met. And put here cross means that this value is divisible by 15. And 75 comes in the table of 25 because 25 3s are 75. So this value is again divisible by 25 because the condition is met. Here 10,064. If I take the sum total of the digits at odd number, is 4 and 0 and 1 5, and at even number 6 and 0 6. If you subtract 5 from 6, the answer will be 1. It's not 0, and 1 can't be divided by 11. Both of the conditions are not met. Here, I'll put cross, which means that this value is not divisible by 11. For 12, this value must be divisible by 4. Yes, 64 can be divided by 4, and this value must be divisible by 3. So if I take 6 plus 4, 10 plus 1, 11, and 11 is not divisible by 12. The second condition is not met, though the first condition is met. Therefore, this value is not divisible by 12, and this value is not divisible by 15 because here is 4. If here it was 0 or 5, then we could consider this value for divisibility by 15. So it is neither divisible by 15 nor divided by 25, because here it's 4, it's not 5 or 0. If it was 5 or 0, we would consider it. Now coming to the 10th, there's 26,124. For 11, I am taking the sum total of the digits at even places and odd places. In odd places there is 4, there is 1, there is 2. If you take the sum total of these, it becomes 7. And if you take the sum total of the digits at even places, there is 2 and 6 becomes 8. If you subtract 8 from 9, the answer is 1. Again, both of the conditions are not met. I'll put here a cross here. And here it is for 12, it should be divisible by 4 and 3. Here it's 24, and 24 is divisible by 4. Let's see, either this value is divisible by 3 or not. If I take the sum total of 4 and 2, there's 6 and 6, 12, 13, 14, 15. 15 comes in the table of 3. Therefore, both of the conditions are met. And this value is 26,124 is divisible by 12. For 15, this value is neither divisible by 15 nor by 25, because at the last here is 4. If it was 5, we would consider it. But here, flatly, we say that this value is not divisible by 15, neither 15 nor by 25. Now, the second law, that is 13,005. If I take the sum total of R, that's 5, 0 and 1, it becomes 6, and even 0 and 3, 3. 6 minus 3, 3, 3, that's not 0, and 3 can't be divided 11. Therefore, both the conditions are not met. The value can't be divided by 11. And for 12, because here it is 5, and whenever there is 5 at the unit place, that value can't be divided by 4. The first condition is not met. I put here a cross. For 15, it should be divisible by 5. Yes, it's divisible by 5 because it's 5. Let's see, either this value is divisible by 3 as well. So it's 5 plus 3 becomes 8, 8 plus 1, 9. 9 is divisible by 3 because 9 comes in the table of 3. Hence, this value is divisible by 15, but it is not divisible by 25, because 5 is not divisible by 25. What other 25 can be divided by 5? Here it's 0, 5. Therefore, I will put here a cross. Coming to the last one, that's 14,400. If I take the sum total of the digits at the odd places, they are 0, 4 and 1 becomes 5. And if I take the sum total of the digits at the even places, 0 and 4 becomes 4. If you subtract 4 from 5, the answer is 1. So both of the conditions are not met. Again, this value is not divisible by 11. To see either this value is divisible by 12, yes, there are 2 0. Whenever there are 2 0, that value is divisible by 4. But see, let's see, either this value is divisible by 3 as well. 4 plus 4, 8 plus 1, 9. Yes, 9 is divisible by 3. So both of the conditions are met. I put here a tick mark, means that this value is divisible by 12. For 15, the value should be divisible by 5 as well as by 3. So it is divisible by 3 and it is divisible by 5. So this value is divisible by 15 as well. And for 25, if there are 2 0 at the last, if there is 0 at unit place, if there is 0 at 10 place, that value is divisible by 25. And this condition is met here. Here is 0 at the unit place, 0 at the 10 place. This value is again divisible by 25. Now you can see none of the value here is divisible by 11. Why? Because the conditions which are required, the two conditions, they are not met. In the book, there may be in the answer given something correct, but in fact, this is the real situation. For example, I am taking this value. Here it is 1, 4, 4, and I am taking here 10 instead of 0, 0. Now, if I take the sum total of this digits at odd number, this is 0, 4, and 1. 4 and 1 becomes 5. These are the digits at odd places. Now, the digits at even places, that is 1 and 4. or 4 plus 1 becomes 5. Let's subtract 5 from 5, the answer is 0. Let's mean the condition is met. Now let's check either the value which I have written here from my own side, either this value is divisible by 11 or otherwise. Yes, the value is 14410 and to be divided by 11. 11 ones are 11. If you subtract 1 from 4, here comes 3. This 4. 11 3s are 33. Here came 1 reminder. This 1. 11 1s are 11. And this 0 is. So, if you take the sum total of the digit at odd places and the sum total of digit at even places, if you subtract one value from the other, if the answer is 0, then that value is divisible by 11. And if the answer is like 11 or 22 or 33, which is divisible by 11, again that value will be divisible by 11. So the value which I have written here, that is divisible by 11. That's all about this question. I am confident that you may understand it. Thank you very much. Thank you.